Good afternoon, my YouTube viewers. In this video, we're going to do a difference in means test, and we're going to compare company salaries. And so basically, what we're going to do is this is a practice question to work on. So the null hypothesis is company A mean equals company B mean. And the alternate hypothesis is company A mean does not equal company B mean. And we're going to carry out a two-tailed t-test to solve this problem. So we're going to write a program in Python to carry out the division in means test, the difference in means test. And we're going to import three libraries that we're going to need to import in order to execute the program. So we're going to import NumPy as NP, which is a numeric library. It carries out numerical computations. It creates NumPy arrays, and it also creates distributions. We're going to import scipy.stats as stats. Scipy is Python's scientific library, and stats is a statistical module within scipy. We're going to import matplotlib.pyplot as PLT, which is the visualization library. So after we have imported our three libraries, what we're going to do is we're going to set our parameters. So A mean equals 55,000, A standard deviation equals 5,000, A size, that's your sample size, is 100. B mean equals 53,000, B standard deviation equals 4,000, and then the sample size for B is 100. And so the alpha is 0.05, which is your significance level. So we're going to calculate the t-score, which is A mean minus B mean, divided by the square root of A standard deviation squared divided by A size plus B standard deviation squared divided by B size. And that gives you a value of 3.1235. Now we're going to calculate the degrees of freedom. So we've got a long formula here to calculate the degrees of freedom using the Welch-Satterthwaite equation. And then that gives you 188.897. But an easier way that you can calculate the degrees of freedom is N1 plus N2 minus 2. So basically, 100 plus 100 minus 2 equals 198. So that would give you a degree of freedom of 198. So, but we went ahead and used the Welch-Satterthwaite in this example, but there's another way, an easier way to calculate degrees of freedom if you want to. And then we're also going to calculate the p-value for the two-tailed test. So p-value equals 2 times bracket 1 minus stats.t.cdf brackets absolute value of t-score, comma, degrees of freedom. So the T means the T-distribution, and the CDF is cumulative distribution function. The output results, we're going to print the t-score and the p-value. And then we're going to analyze the p-value. So if the p-value is less than alpha, then that means you're going to reject, and alpha is 0.05. So that means you're going to reject the null hypothesis, and there is a significant difference between the mean salaries of company A and company B. If the p-value is greater than alpha of 0.05, you're going to fail to reject the null hypothesis because there is no significant difference between the mean salaries of company A and company B. So now we're going to plot the t-distribution. X equals np.linespace brackets -4, 4, 1000, and y equals stats.t.pdf brackets x, df. So T stands for your t-distribution, and PDF is probability density function. Now we're going to plot the t-distribution onto the graph, plt.plot, brackets x, comma, y, comma, label equals t distribution, comma, color equals blue. So we're going to shade the critical region. Critical value equals stats.t.pdf, brackets 1 minus alpha divided by 2, comma, df. So T is your T distribution, PPF is percentage point function, alpha is 0.05, and then df is your degrees of freedom. And plt.fill between brackets x, comma, 0, comma, y, comma, where x is less than or equal to negative critical value, or x is greater than or equal to critical value, comma, color equals red, comma, alpha equals 0.5, comma, label equals critical region. So we're going to mark the t-score on the plot, plt.axv line, brackets t-score, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, comma, label equals t-score. So we're going to add titles and labels to the chart. So the title is Two-Tailed T-Test Comparing Company Salaries. The X label is t-score. The Y label is probability density. And then you have a legend. So we're going to plot the graph. So we have a degree of freedom of 188.897 because we used the formula. But if you don't use the formula, then it would be 198. Your t-score is 3.1235. Your p-value is 0.021. So the p-value is less than the alpha of 0.05. So that means that you're going to reject the null hypothesis, as there is a significant difference between the mean salaries between company A and company B. So the blue line is your t-distribution, the red is your critical region, and you can see that your t-score of 312 is well into the critical region. So this completes our video for salaries, and the next video we're going to cover another difference in means, and so I hope you decide to watch it.